Welcome back. So we're going to welcome Chris Norman. Chris is the co-founder of Common Fate. And we also want to thank our bronze sponsor, Tigera. They are the creators of Calico. They do secure networking and comprehensive protection for containers and Kubernetes to prevent, detect, and mitigate security breaches. So Chris is going to talk to us about building your own CloudTrail.
How's it going, everybody? Okay, today we're going to build our own CloudTrail. Now, I know it's the very last talk of the conference. I'm the sole person standing between you, the beers, and the after party, so I'll keep it short. I'm going to try and keep it fun. Before I get started, a huge thank you to all of you for showing up today for the inaugural for cloudsec. A big round of applause to everybody. A big thank you as well to all of the organizers and sponsors for making this happen. And also a special shout out to Brandon Sherman for your advice in helping to prepare this talk, so thank you. My name is Chris. I'm the co-founder of Common Fate. We help make cloud access faster and more secure. We build a just-in-time workflow access product. I'm also the creator of Granted, which is a multi-account AWS access CLI. It's similar to AWS Vault, but it's really good at managing multi-account access and helping you get easy console access. We get a show of hands if anyone here has used Granted before. Oh, amazing. Yeah, check it out. It's really good. I use it every day, and kind of built it for myself. And again, I'm going to be talking about building our own CloudTrail today. So what I mean by that is a little bit of background on CloudTrail. It's the audit log layer for AWS. It helps us infer who did what and at what time, and it captures all of the control plane operations that are happening in our AWS environment. The events that you get look like this. So we get kind of a JSON payload like this, and it audits all of the control plane operations, even those which were not permitted, unless you're Nick Frechette, who's given a really good talk last year about trying to bypass CloudTrail, and just wanted to shout that out. Okay, so we're going to be building our own CloudTrail, and I'm going to be taking a little bit of a worked example here. Now, I am absolutely atrocious at managing my expenses, so I thought I'd kill two birds with one stone. We're going to be taking a receipt tracker application as an example. We'll be walking through this and how we protect our application using and ultimately end up developing our own CloudTrail. Now, the application that we have is a workload which is going to be running in AWS, and I'll point back to a few services that we're going to use to help build this. What we're going to have is similar to AWS CloudTrail. Our CloudTrail is going to protect and audit all operations to my workload in the cloud, so even those which aren't permitted. And we're going to ultimately end up with JSON payloads that look similar to this. So we can draw some parallels back to the AWS CloudTrail slides that I showed before. Okay, we're going to build our own. I want to give a few caveats though. AWS CloudTrail is operating at a scale of 1 billion requests per second. The talk that I'm going to give today with my CloudTrail is not going to be as many requests. We're not going to focus as much. I've only got 20 minutes. We're not going to talk about scaling out massively. I do think that this architecture can get to reasonable scale, but I'm going to focus less on this for this particular talk. AWS CloudTrail logs events for 200 AWS services, probably over 200 now, across 108 availability zones. My focus today is on logging events for my own workloads that are running in my AWS environment. And it's also going to include some data plane level audit logging to access data that is stored in AWS service. So I'll give an example of that with S3. Now, finally, AWS CloudTrail has been built with the knowledge of AWS IAM internals, whereas my CloudTrail has been inspired by what is publicly documented and available, but I'm not internal to AWS, so I may get some things wrong with, and maybe some AWS folks want to point those out to me. Okay, a little bit of background here. So this is me, maybe about 6 months ago. I'm very happy. I'm working on my product. The particular kind of component that I'm working on is around authorization for like cloud access workflows. And then suddenly we start to get some feature requests coming through. So first feature request, can we allow users to authorize some access if they're on call? I'm going to get another feature request. I'm a little bit unhappier. Can we get auto-approved access if they're on call and in a certain IDP group and requesting access to a certain account? And then I got really unhappy where we say, can we have auto on call in a group, accessing an account in the corporate VPN, and it's during working hours, and it's a full moon. So the use cases that we were trying to solve for internally became quite complex, and we realized that we needed a policy layer. Some of the properties that I wanted in the system that I was building was testability. So I wanted to be able to model policies as code and to be able to reason about my authorization independently to the services themselves that I'm trying to develop. I wanted to be able to test and simulate these policies. I wanted it to be simple, so I wanted to avoid introducing external dependencies. I wanted to avoid introducing sidecars to handle the authorization, and avoid introducing like new sort of areas to go and store state for authorization purposes. I wanted it to be expressive enough to model those kind of complex authorization use cases, and that leads us to kind of models such as role-based access control and attribute-based, access control. And then finally, I wanted it to be auditable. So I wanted to be able to authorize every operation and then audit every authorization. And for those following along, this is the kind of component here linking back to my CloudTrail. Good news is that there's a bunch of open source technology that we can adopt to help us implement such a solution. I've got a bunch of them listed here. It's definitely not exhausted. There are some really great tools and technology that's out there. And I'm going to, broadly speaking, categorize these into kind of two broad categories with how I like to think of these in a mental model. We have centralized and local. So centralized technology is similar to Google's Zanzibar project. Can I get a show of hands here who's heard of Zanzibar before? So we've got quite a few of you in the audience who've got some level of familiarity with it, which is good. With Zanzibar, authorization data is stored in a central, globally available database. The distinction here that I make between centralized and local is my mental model for how AWS IAM works is more similar to the local case, where the authorization data is stored in the existing, alongside the existing data that is used by a workload, rather than being made available in like a global authorization database. And ultimately, when we chose to build this, and when implementing my system, I opted to use a technology called Cedar because it was the best fit for the particular requirements that I marked on previous slides. So, what is Cedar? Cedar is a new open source policy framework created by AWS and open source last year. It's available under an Apache 2 license, and it's a language for defining permissions as policies which describe who have access to what. It's available in a bunch of different languages, so there's a couple of different implementations available for it with bindings to quite a few different languages. And it is available as an AWS managed service as well, although that's not going to be the topic of, that's not going to be the focus of what I'll be discussing today. I'll be talking about using Cedar in an embedded context within your workloads running in the cloud environment. This is what an example of a Cedar policy looks like. So the model, generally speaking, is the principal, action, resource, and context model. And for those of you who've written AWS IAM policies, this will feel really familiar to you. It follows a very similar sort of like policy structure. The difference is that Cedar can apply to any authorization scenario, whereas AWS IAM only works in AWS. Now, taking my very disgruntled user who's come through with quite a complicated authorization feature request, using Cedar, I can model this in quite a concise manner. So you can see about 10 lines worth of policy code. It is quite readable. It is written in code, so it's not expressed in English, but you can see you can kind of read from top to bottom and get a pretty good feel of like the conditions which are going to permit this particular authorization. Now, taking our receipt tracker service again as an example, we're going to model this using Cedar. So I've got an example of a schema. Cedar supports strong typing, which allows you to define the particular actions, entities, and namespaces involved in your application. And you can see here that I've got a model for my application that I'm building. U've got a user, I've got a receipt, which can be owned by a user. I've also got an action called getReceipt, which applies, which a user is able to go and call on a particular receipt. What I wanted to point out in particular is that I can also model S3 and I can model cloud provider APIs in Cedar as well. And this allows me to form what I'll call maybe a permissions overlay where I'm able to authorize first in Cedar and then authorize again in AWS IAM. And I think that this introduces a little bit more flexibility for protecting workloads in the cloud, which is why I'm very excited by it. And I'll show you a little bit more about that as I go through the rest of the talk. An example policy for our receipt tracking service is going to look like this. So we've got a permit action where maybe we're allowing people to call the get receipt on any resource when they're the owner. So why Cedar? For these reasons, the policy language is very expressive, it's performant, and it's analyzable. Cedar has been built with a formal model around the security properties, and the team at AWS have evaluated the actual implementation against this formal model. From a performance standpoint, again, I wasn't talking about getting to 1 billion requests per second, but one of the things that I am very happy with about adopting and using Cedar is that it scales very well. This is a comparative chart here. For those at the back, you may not be able to see the particular indicators on the chart. But this is a comparison between Cedar, Rego, which we've had a previous talk about today with Open OPA, and Open FGA, which is a Zanzibar implementation. And Cedar performs really well at scale as you increase the number of entities involved in an authorization decision. I wanted to quickly call out the AWS IAM architecture, and Becky Weiss has a fantastic talk about this, going through some of the internals, and this has really formed part of the inspiration of kind of the system that I've been building using Cedar, namely the separation between a control plane where the policies are written and uploaded, and a data plane which actually performs the authorization. This fits my model for local authorization because in my mental model of how AWS works, the data in a particular resource is, remains in a particular regional data center. Now, let's go into the architecture a little bit. I'm going to point out some of the services that I've been using to go and build out this example here. So we've got a few different components. We've got a web UI and we've got an API. We've also got a storage backend for our receipts, so that's going to use S3. And finally, I've got some of my auditing and authorization pieces. I've got a control plane which my workload running in the cloud is going to connect to read the policies. And I've also got some ingest and storage for the audit logs themselves. So going through this, the Cedar policies are written to a control plane, and then they're propagated through into my authorization data plane. Now, I wanted to point this out because this is very similar to my mental model for how AWS IAM works. We're going to run through the request lifecycle and how we actually run the authorization now. So to begin with, Alice is going to make an API call. So she's going to go and try and get a particular receipt. We're then going to make a Cedar authorization to determine whether or not that this operation is permitted. In this case, the operation is indeed permitted. So what we're going to do next is we'll write the audit log into our storage ingest. And finally, after we've authorized the operation, we'll actually go and perform it. And then in this case, we go and call the corresponding AWS S3 API to go and return the object, or perhaps we're just returning a pre-signed URL for it to be sent back to the client. And again, I wanted to go and point out that this was my CloudTrail, and these kind of components here are what are similar and inspired by AWS CloudTrail. And we get a little bit of thumbs up again. Now, maybe the most controversial slide here is that I am a big fan of AWS IAM. Maybe having a love-hate relationship is a better way to go and describe it. But the things that I do like about AWS IAM are these components here. So I'm a big fan of the fact that us, as cloud security practitioners, can write policy as code. We can lint, validate, and go and check in our policy as code using GitHub. We can deploy it using Terraform. We've got some fantastic tooling to go and validate the IAM policies. A big shout out to Scott Piper for your work on Parliament. And we can also do automated analysis of our IAM policies. Question here is, can my CloudTrail style system do this? Policy as code? Yes, of course. Cedar is a code-first policy language, so we can absolutely implement this. Testing, the answer is yes as well. I've authored a blog post on testing Cedar policies here. There's also a really good blog post written by AWS on how to do the testing piece. Validation. So we can validate the policies against a schema. So for example, I've got that schema that I mentioned before. We're showing which actions, which resources, which types of entities are actually valid when we author the policy, and we can validate those and check them using things like GitHub Actions. And then finally, automated analysis. Nothing exists for this today, but the language and the framework has been built with this in mind, and it's an area that I'm really excited to see growth in. So I'm going to pause here. because you're probably thinking, Chris, I'm a cloud security practitioner. This isn't Ford AppSec, this is Ford CloudSec. Why should I care? And my answer, I've got 3 points for you here to pitch as why I think everybody in this room should actually care about a system like this. First of all, it's about securing our workloads that run in the cloud. And we think about the shared responsibility model. That's something that falls on our side of the fence as customers of a cloud provider, is to secure these workloads. The second point is that it's a cost-effective approach to auditing AWS data plane events. So what I mean by this is that you may not necessarily have data plane level CloudTrail turned on in your AWS organization, but you can use a technique like this to be able to get insights and analytics on authorization events which are happening, which relate to your data plane. And by doing this approach, you can choose to sample, you could choose to allocate this to a subset of services, you can kind of slice and dice this as you like and implement it on various workloads as it makes sense for you, rather than simply allowing it for everything across the board and spending a whole lot of money. And the third thing that I think is really interesting is that it allows us to link the application context for the developer teams back into a cloud security context. So you can actually tie these authorization events through into a particular request ID that may have been emitted through to AWS CloudTrail, perhaps. I'll show you a little bit of what I mean by that in a live demo. I'm going to dive in and show a little bit of an example here, and I've also got a live demo which I'm going to open source at the end of this, so you can have a bit of a play around with this yourself as well. The example that I have is in my receipt app, there is an API which allows access to Alice and Bob's object. Now, the problem I have at the moment is that when Alice is accessing this API, the IAM role that I have defined for the service at the moment doesn't have her context. It's just been allocated for the service. So I have potentially a risk where I can go and access other people's S3 objects. Using Cedar, I mentioned before about the concept of having it as a permissions overlay. So using this, I authorize first with Cedar, which determines whether or not an end user is able to permitted to do something. And then secondly, it uses a service authorization to actually perform the call. And so in this case here, we can actually adequately protect against it. I've got a couple minutes left, so I'm going to give it a very quick live demo. And this will be published on GitHub as well, as I mentioned. OK, so I've got two sections here. The first is my control plane. So this is where I'm going to be editing our policies and ultimately where we're going to start seeing the CloudTrail events. The second is the actual application itself. So I'm currently authenticated as Alice, and I can see a couple of receipts here. So we're going to log in. We can see, OK, I've got a receipt from Little here. Let's go back into the control plane. And we can see we're starting to receive some events that are coming through. And I look in the audit log, and let's grab this one as an example. I can see that similar to the kind of going back into the very beginning of the slide deck, this JSON payload here is the CloudTrail that I've built kind of for my own workload, which is running and deployed in AWS. I can see the decision that was made, whether or not it was permitted or denied. I can see details about the operation. I can also see information about the authorization which was performed. The example here that I also think is very interesting is you can include AWS request IDs for operations which include invoking the AWS SDK. And so in this way, it helps tie what is happening inside your application through with what is happening in your cloud environment. We've got a problem in the application at the moment, and this is that Alice is actually able to go and access some of Bob's data. And I'll show you what I mean by this now. So we've got two users here. We've got Alice and Bob, and we've got three different receipts. We've got receipt 1, 2, and 3. Receipt number 2 is Bob's, and we've got 3 S3 objects which correspond with these receipts. So again, number 2 is Bob. I can look back in the app here. I can see this might be a little small for you if you're browsing on viewing online or at the back of the room, but this is number 1. I can go back, view number 3, and then if I go in and look at number 2, whoa, hold on, I can go and access some other users' S3 like an object, a receipt, which has been uploaded here. Let's go back to the control plane now, and we're going to go and fix this up using Cedar. So I'm going to go back through. I'm going to go into the policies view. This is the current policy which has been deployed. So I'm allowing anyone to call the get receipt if they're the owner. But I can see here in Cedar, this is currently too permissive. So I'm just allowing anyone to call the get object action on any resource. I'm going to go and fix this now. And I'll say when principal is equal to the resource owner. And you can see that actually I'm able to, because we're using Cedar, we're able to reason about our authorization separately to our workloads and applications running in the cloud. And so I can see a preview and a diff of the changes that are going to be made to the authorization. I can see here that we're going to lose access to some of these actions are now going to be denied. And then the final piece here is that I have some tests. And the tests previously were failing. So if I pull this back to what it was before, you can see that this cross-user S3 access was failing before. Now when I pull this back through, all of my tests around my policies were passing. I'll save this, and now we can go back into the app, and now the authorization issue has been fixed. And I'm able to reason about that in a control plane which is independent to my cloud workloads. I want to go, I think I'm nearly running out of time, but a few very quick takeaways, and happy to answer questions as well and chat about this afterwards. But one of the main takeaways here is that I think as cloud security practitioners, we're actually industry leaders in using policy as code. We're very familiar with constructs such as AWS IAM, and I think that we lead and need to educate our developer teams and the kind of the wider security industry about some of the benefits and some of the practices that we use with cloud security providers. My kind of call to action here is to consider adopting a framework like this if you're not already using something similar to this, either for user to service or service to service, authorization. And finally, a few links here, and the code that I'm sharing and that example application has been published to GitHub and open sourced. Thank you so much.
Thank you, Chris. So there's one question on Slack. You said that you love AWS IAM. Is that just a cry for help?
Sorry, what was the question?
No, that was just a troll question. I don't think we have any question in Slack. Someone is saying that granted is great.
Oh.
Any question in the room?
Thank you. Hi there. Do you have any advice if someone starting from zero in terms of these kinds of frameworks, tools? Do you have any advice to adopt it?
Great question. I think that to begin with, you could talk to your development team about even simply emitting audit logs when a particular API call is being made. So if you were to start, if I was to go into a brand new team and I'm very unfamiliar with the application, and I want us to start getting some insights like this, the kind of audit logs that you can get out, maybe the development team can add them into the middleware that they're building in their applications, and then you can start to get a little bit of a picture around this. I think that the natural challenge with adopting policy as code like this is that it can be quite foundational to your workload. So the other thing maybe to think about is if you're introducing a new service, that could be a good starting point for this rather than trying to re-engineer existing workloads in the cloud.
You discussed You discussed automated reasoning with Cedar. Could you elaborate a little bit on what's been made open source for that? And do we kind of have like these Zelkova-like capabilities for Cedar? What do we have? What do we don't? And how?
Yeah, great question. So what is currently open source, and this is also maybe to my knowledge, so I might miss a couple of things here, but what's currently open source is a formal proof of the security properties of Cedar, and that covers things such as a forbid statement always overriding a permit, which when you're building an authorization policy language, that sort of invariant is really, really important. And so the Cedar core team has created that proof, and that uses, I believe that they use some SMT technology around verifying that the kind of formal proof there, they basically fuzz the implementation against that proof to determine that it's correct. There has been a little bit of research work as well around condensing and kind of simplifying policies. The idea here is that you might have like multiple policy statements that you could reduce down into a more concise version. There's a recent paper, maybe I'll update the talk slides to include a link to the paper at the end, but it's something that AWS Science has published recently on the topic.
Yeah, the interesting thing is that it has a formal semantics written in lean for a theorem prover, so you can use that for reversing. But as a practical matter, putting theory, my favorite topic, aside, one of the differences between audit logs and ordinary data logs is, of course, that we have some intuition about what constitutes an auditable action that's important as opposed to this mass of things. And secondly, we want the audit logs to be tamper-proof. Have you found interesting ways, on practical matter, to annotate, say, Cedar policies or other policy languages to say, these are the important things that need auditing, and these are just ordinary operations that don't? And secondly, how do you, as a practical matter, recommend segregating those logs you're getting out of your system here that are running in those Lambdas into a place that's a S3 bucket or something else that you can also isolate and maybe even prove can't be tampered with, or at least is tamper evident?
Yeah, great questions. I'll talk a little bit about the implementation that we've been using in production for this, and maybe less so on the example, just to give some better context. I think our approach, we tried to keep it as simple as possible when it came to implementing, and also the kind of the back end that we use to capture these decisions. The implementation of trying to segregate these logs, either maybe in your application code, it could actually be a separate sort of emitter. So in production, we write these to AWS Event Bridge, and that's a separate stream that we write, which is distinct from the rest of our application observability kind of tooling. The other thing that have also been kind of playing with and sort of implemented proof of concepts for is simply adding like a security tag to the to structured logging that your application emits, and then you kind of segment all of those things out. At work, we use OpenTelemetry as the main kind of backend that we stream all these events through, and so you could process those and store those separately. We at the moment we use S3 to go and store these events in. We haven't yet gone down the route of making the audit logs tamper-proof. The kind of control that we've implemented, at least for the sort of the system, is that the auditing bucket and the rest of the infrastructure lives in the customer or user's own cloud environment, and that helps to protect against, at least it's kind of something that they own and they can secure.
So it's evident it gets tampered by you. That's good.
Yeah, indeed.
Thank you very much, Chris.